Cool. All right. So, just a quick reminder in Unit 4, we've got two more lessons to do and then our post test. So, what I want to do is today do the linear inequalities lesson. And then tomorrow we'll look at the next one. Wednesday, our absolute last day we can do anything. We're going to do our test together as a group. And if you do it on your own prior, that's all good. There we go. Now it's working. But if you want to do it with extra support, then I want you to join me on Wednesday morning and we'll do our post test for Unit 4. And then also, I've seen a lot of you catching up on Unit 3 stuff. That's terrific. Don't stop. Do your best and try to finish all of Unit 3. Tomorrow's Tuesday, so tomorrow at 3 o'clock, I'll be able to do extra time in the afternoon at 3 o'clock for anyone who wants extra help. And one person joined me today at 10. You're welcome to join me tomorrow morning at 10 o'clock. I've got some Math 2 students working too, but we can all work together. So extra math support from me tomorrow morning at 10 and then at 3 o'clock. So lots of extra help if you're willing to take it, if you need it. Otherwise, have Unit 3 finished, and we're going to have Unit 4 finished as a group on Wednesday. So today's new lesson is called Linear Inequalities from Unit 4. We're mixing together the concepts of graphing a line and using an inequality. So we're going to mix together these two different concepts, but they do go well together. So we're taking our whole graphing a line, graphing a function, and then the idea of a greater than or less than inequalities. And that's what this lesson is about. Let's do this quick review together. This is single variable. So last time we did inequalities in Unit 1 or 2, it looked like this. So the first one we have is x greater than 6. Greater. Greater than 6. And then the second one is x is less than 6. One way to remember if you're looking at a greater than or less than symbol, like which one is it, is as you read it, which side of the sign do you get to first? So the top one is x is greater than. And we know that because you reach, as you're reading it, you reach the open side. So this is like the greater than side. And the second one, x is less than 6, you reach that pointy, small arrow point, right? So that's our less than side. For the last two, would anyone be willing to tell the group what those ones are, or at least what number 3 is? If this is number 1, number 2, and number 3.
Number 3. Oh, sorry.
No, go.
You're fine.
Go, Anaya, go ahead.
Okay. Number 3 is greater than or equal to 6.
Yes. Thank you for jumping in. And since you're here, what's number 4, if you don't mind?
Less than or equal to 6.
Thank you so much. Greater than or equal to. It's kind of a mouthful, right, to say it or to write it, but that's what that little extra line means. That's like saying it has equality as well as greater than. So if you see the little bar underneath, that's like half of an equal sign. It basically means it's equal to the number and it's greater than the number. And then likewise for the bottom, we've got x is less than or equal to. We're going to be using these today with our functions. With instead of y equals mx plus b, we'll have y is greater than mx plus b, or y is less than or equal to mx plus b. That's what we mean by mixing together. So we'll see some examples next. Make sure to have this written down or have a picture of it because we'll be using these symbols. I'll wait 15 more seconds in case people are writing, and then we'll move on. And if you need more time, just please tell me. What is today? The 13th. Monday the 13th. That's awesome. It's like Friday the 13th, but happening on the other worst day of the week, Monday. Just kidding. Okay. Savannah's here. Levi's here. Beniam and Robel. Brooke and Savannah. Savannah and Anaya. Cool. 1, 2, 3, 4, 5, 6. All right. Next. Oh, I'm going to skip this review for now. Here we go. Let's jump into this. Graphing linear inequalities. So here's our 3 steps. And I'm going to start this with an example. So our 3 steps are these, what I have in lines. So graph the line like normal. Question you ask yourself, is it dashed or solid? Shade above or below the line? So we're going to treat it as if it was like this. Y equals mx plus b. So when we graph it in this format, we look to the b value first. That's our y-intercept. Me and Levi were doing some of this earlier in the 10 o'clock hour. And then you follow slope to tell you like where to go for the next point. So if we were to graph this line, we're going to start it like this. Here's my x and my y. You begin the function or the line at +1 because that's our y-intercept. Okay, so I'm going to change to purple. So start at +1 on the y-axis right here because of that +1 in our equation. Then follow slope. Since it's 2, we go up 2 over 1, starting from our purple point. So up 2 units over 1 unit to right here. And then let's put another one in there just for good measure. Up 2 more over 1. So even though I'm just eyeballing this and doing kind of a sketch, it came out to a nice straight line. Now, normally we would just connect the dots and graph our line, but this is an inequality. This reads as y is greater than 2x plus 1. I'm going to write that down below here so you can reference it. Y is greater than 2x plus 1. Think of the y as what we're going to shade, and think of the 2x plus 1, the mx plus b. Think of that as like the line itself. So since this is y is greater than, not greater than or equal to, instead of making a solid line, Watch this, double check. We're going to make it a dashed or open line. So I'm connecting my dots, but I'm not drawing like a hard straight line through it like normal. Instead, we're just going to show it as a dashed line, just like when we did our earlier inequality graphs. We would leave it an open circle for y greater than. We're going to make our line a dashed or open as well. If it were to have the equal sign below, then we would make it solid. So I'm going to add this into my rules on the left. So we do dashed line when it's greater than or when it's less than. We do a solid if it were greater than or equal or less than or equal. One more step. We shade above or below our line, but how do we know which one to use? Shade above for greater than or for greater than equals. Shade below for less than or less than equals. Now I'll show the shading in just a sec. I'm going to change my color again so I don't. We'll change this to yellow. So I'm going to shade half of my whole graph, either above the purple line or below it. Because our example is y is greater than, then I want to shade above the line I just made. So here's my purple line. I want to color in, shade everything above that purple line. Basically. Any questions right now? Concerns? So we're kind of doing 3 steps if we're to graph a linear inequality. Linear means line, and inequality means like greater than or less than, right? So whenever we have a linear inequality, we've got to figure out what our line looks like in step 1. That's like making the line. But then we have to, before you actually draw it in, make sure you're going to do the correct line. Is it dashed or solid? If it has equality, then it's solid. If it doesn't have equality, it's just dashed. Then we're going to shade, that's step 3, above the line for the greater thans or below the line for the less thans. Okay, if there's no questions, let's look at another one. Here's a new inequality. 7x minus y is less than or equal to 3. Let's talk about these questions above. Will this inequality have a dashed or a solid line? Also, will we be shading above the line or below the line? Now, this is not in y equals mx plus b form, but we do see our symbol. And this symbol is going to tell us like dashed or solid. And it tells us shade above or below. But let's first put it into y equals mx plus b form. So 7x minus y is less than or equal to 3. A little bit of algebra. So this is good practice for solving equations. I want to solve this inequality for y. Right now, it doesn't have y all alone. So if you're given one in this format where x and y are like together, let's start by rearranging it, resolving it for y. So let's minus 7x from both sides of our inequality sign. So these ones cancel on the left. And then last step, we don't want it to be negative y or minus y. We want it to be positive. So to fix this, we're going to multiply everything, left and right side, by negative 1. So imagine doing a negative 1 times each term. So that would fix our y problem, our y issue. And it turns the 3 into negative 3, and it turns the negative 7x into a plus 7x. Remember, when you multiply by negative 1, you're basically changing all the signs. Positives and negatives switch. And then another thing to remember from when we last did inequalities, if you multiply an inequality by negative anything or divide by a negative number, it switches the direction of the sign. So here's our final result in the box. So now that we've like rearranged it for y alone on one side, y equals mx plus b form, notice that our sign has changed directions. We had to do that because we had to multiply by the negative 1. So how do we say this inequality? Y is greater than or equal to negative 3 plus 7x. Or if we wanted it to be rearranged further, we could put this, we could change the order of the 3 and the 7x. So it would be 7x minus 3. So our b value is negative 3, and our m, our slope, is 7. So looking at that equation, will we be shading above or below the line? Any thoughts?
Um, I think you're gonna shade um, above the line because the direction of the greater than equal to sign
Correct.
changed.
Very good, Levi. Thank you for jumping in with that. We're shading above. Very good. Yeah, the direction changed. When the equation first started, it looked like over here, y less than equal to. But because that y was negative, we could see that at the beginning. After we did our work, it changed the direction of the sign because it was negative. So we're going to shade above for this problem. And then anybody, will it be dashed or will it be a solid line? The symbol is greater than or equal to. Because it has that equal to at the bottom, greater than equal to, we know that the line would be solid. So solid line. So when we make this inequality, when we graph this inequality, we know that the line would be solid because it's got the equals in the symbol. And we could tell that at the very beginning, even before rearranging. It is best to do your rearranging to know for sure which direction the symbol's pointing. That tells you, do you shade above or below, like Levi pointed out. Okay. No questions? Or are there any questions or comments? It's okay if there are. Let's look at another one. Actually, I want to find something like this. Let's try this one. I want to try find a different type of problem. So here on the right side, we have a graph. We see our dark red line going through, kind of like in the middle, and we see half of it shaded in pink or like reddish. Our job is to write the inequality. So to do this, we need to come up with the right numbers for slope and for the y-intercept. And then we've got to put the right symbol in there. And is it less than? Is it greater than? Does it have equals to, or is it just less than greater than? So several points to take care of here. So let's do this in parts. What's the y-intercept? Examine my graph, and can you see where the dark red line, the function, is crossing the y-axis? At what height is it crossing the y-axis? Anybody?
-1.
Very good, Levi. Right here. That's what Levi's seeing. The red line's crossing at -1. So that tells us our b is -1. I'm going to put it in below the equation I have on top. Now for slope. Slope is tricky, but we've been practicing this for a while now together. To find slope from a graph, we want to identify another point along the graph where the function line is going through whole numbers. So I see this spot here. I see this one way up top. And on the left side at the bottom, I see this spot here. So any of these red points I made will work for counting our slope. So from one to the next, from any of those points of whole numbers to the next, it looks like it's going up 3, 1, 2, 3, and then over 1, 3, 1. And check it out for the other ones. It's the same pattern. Up 3, over 1. So as a rise over run, it would be 3 over 1, or just plain old 3, slope of 3. So here's our like equation, basically, 3x minus 1. Let's put our y in there, and now we've got to deal with the symbol. So you all see the graph. Is the shading above or below the line?
Above.
Above. Thank you. So that means we're going to definitely have y greater than the 3x minus 1. And then you also, again, look back at the graph again, dashed or solid line. They gave it to us as a solid. So that means it's going to be y is greater than or equal to. Because it's solid line in the picture, that tells us this has got to be have the equal to in the symbol. So solid line, I'm going to add this in as a note. Solid line means equal to in the equation. So lots of different parts here. We've got to be able to identify our y-intercept, identify our slope, put them into like a y equals mx plus b, and then you've got to investigate which symbol am I using for my inequality. Greater than, less than, equal or no equals. If you'd like to just take a picture of this page, I understand, that's fine.
I have a question.
Please, go ahead.
So you said that it's a solid um, symbol because it's a solid line. But what do you like? Can you explain that? Like, how is it a solid line?
Yeah, because looking at the graph they gave us, we see it's pretty clear to see like the red and the white. You know what I mean? Like we can see the red shading and then the unshaded white zone.
Yeah.
In between them, we see this like solid line. Solid meaning like filled in, like a normal line. It's like a normal line, as opposed to this next to it. I'll show you a dashed version. Looks like the lines in the road.
Oh, okay.
So this is what we would mean like comparing it to. So it's either going to be solid filled in or it's dashed like road lines.
Okay.
And then this, if it's a dashed one, we would be using the greater than symbol without the little equals. So let me add that in for my notes here. So it's, if it were dashed, it would be greater than only, no equals to. Does that answer your question, Anaya?
Yeah,
Okay.
it does.
And I should have one of those coming up next week in practice. Good. So here's an example, Anaya, of a dash line. So it looks more like the lines in the road. And that's our symbol meaning, or a signal really, that's saying this is going to be either greater than or less than, not, greater than equal to, less than equal to, because of that dashed. So so let's start this like we did the last one. I'm going to kind of put in a skeleton on the left of our blank equation. Y equals mx plus b. We've got to find the right b, find the correct m, and then deal with the symbol. So for b, that's the best place to start usually. Where's the dashed line crossing through the y axis? This time it's crossing through at 3. So I'm going to put a 3 under my b there. That's my y-intercept. And now we've got to deal with the slope. So find more places where on the line it goes through whole numbers. So I see one right here. And actually on my picture, that's the only spot. I don't see another one we could use for this example. So now tracking from like the first point to the second point, how far down? 1, 2, 3, 4. It's down 4, so that's going to make it negative over 1. As a rise over run, let's put that in here. Our slope is down 4 over 1, simplified to just plain old negative 4. That's our slope m. So negative 4x plus 3. It's plus 3 because it was crossing through at positive 3, not negative 3. So on the left side of the screen, we've got all the right numbers put in there. Now we've got to deal with our symbol. This time, folks, look at the picture again with me, the graph on the right. Does it look like it's shaded above the dash line or below it?
I think it would probably be below.
Yes. Very good. Yeah, go
And
ahead.
the reason I was going to say that is because of the way the line is going. Instead of going like this direction, it's going this direction.
You're right. This time the slope is negative, so it's going downward instead of upward. Totally. Um, a common thing I've noticed when working with students, or just in life, even before teaching, it's easy to get into the habit of thinking like the left side or the right side, but we don't want to do that. I want to really push you and encourage everybody to always think above or below, greater than above, less than below. Because the left and right can change depending on the slope, like Levi pointed out. I mean, this looks like it's the left side of our graph is being shaded, right? But I'm going to go back real quick to this one. The left side was also being shaded here. This is our previous example. But this was above the line. This time, the left side is shaded, but it's below the line. So always frame it to yourself as an above or below. Am I shading above or below? So identify your line, and then you're saying, okay, at any given like vertical spot, like if I drew a vertical line through anywhere, a straight up down arrow, now it's easier to see the top above our line, and then down here is below. And the shading is in the below spot this time. So that's our signal that we're going to use less than. Y less than negative 4x plus 3. Y less than the line. So I always think about it as we're shading y, and then this whole section, negative 4x plus 3, that's our line, the line itself. So we want to shade whatever y is, shade below in this case. For that like test to see am I shading above or below, you can use the vertical axis, the y-axis, if that's helpful. Like looking at the y-axis is the top of the line or the bottom of the line, the shaded part, and that'll tell you which symbol. Okay, one more topic, and then let's look at some questions from the mastery test. This will come up too in the mastery test. Which test point is a solution for this inequality y minus 3x less than or equal to 1? So what do they mean by test point? These 3 points, 5, 1, 0, negative 2, and 1, comma 2, these all exist out on our graph. However, it counts as a solution. I'm going to add this at the top. Solutions to these linear inequalities fall inside the shaded region. Solutions to linear inequalities fall inside or live inside the shaded region. They're shaded inside the shaded region. So basically, if it's out in the white zone, the unshaded zone, it's not a solution. If it's in the shaded zone, it's a solution. We can do these kinds of questions by graphing them, and we can do them algebraically. So let's graph it quick, and then let's look at how to do it algebraically. So I'm going to try to make my my picture, my graph. Now, it's the problem or the function wasn't given to us in y equals mx plus b form. It has the y and the x together. That's a bummer. So step 1 is going to be to take what they gave us, like this, and rearrange it like we did earlier to put it in y equals mx plus b form. Because it says y minus 3x, I want to add 3x to both sides, like so. And we're basically moving it away from y. We're canceling it out on the left. Y is less than or equal to 3x plus 1. We don't flip our sign this time because we didn't multiply or divide by a negative. All we had to do was add a 3x to both sides. So here is our inequality. So to graph this thing, we know we start at the plus 1. So here's my plus 1. I'll put a nice big point there. And then our slope tells us we're going to go up 3 over 1. So I'm just putting in a few units here. From 1, we're going to go up 3 spaces over 1. So up 1, 2, 3 over to 1 here. I'm going to change my color to purple quick. So here's my second. I'll just make them both purple. Here's our 2 points we found. Now, before you put the line in, always double check your symbol. This is y is less than or equal to. Because it has that equal to, like Anaya was asking about and pointing out earlier, that equal to is going to mean make it a solid line, just like normal, as if it weren't even an inequality. So I draw you can go ahead and then draw in a solid normal line through the 2 points. And now for the shading, it's y less than, so I want to shade below my purple line. Not on the top, but it should be on the bottom. So I'm going to change to yellow so I don't cover everything up. I'm just going to do some lines like this, if that's okay. So here's my shading in yellow. So there's our graphed inequality. Cool. Now let's see which of these points, A, B, or C, fall inside the yellow zone. So 5 comma 1. I'm going to change back to purple for my points. So point A, 5 comma 1, that would be over 5. I'm sorry, to the right 5 and then up 1. So we can kind of see that's going to be in the yellow zone. So if I started at 0, 0 in the middle and go over 5, that's over here. And then up 1, boom, here's point A. So that's a solution. So A is a solution. 0, negative 2. So that's 0 left or right. So right in the middle and then down 2. That's point C. Or I'm sorry, point B is in bumblebee, and that's in the shaded zone. So B is also a solution. And then C is 1 comma 2. Oh, this is dumb. Why did I pick these 3 points? Okay, so C looks like it's also a solution. Over 1, up 2. All right, my bad. That was a poor setup. I should have. So they're all 3 solutions, but let's look at one that wouldn't be. I'm going to add in like negative 2 comma 5. So point D, I'm adding it in. Negative 2 comma 5. So that would be starting at the middle, going left 2 this time, up 5. So here's point D way up here. It's in the non-shaded zone. D is not a solution. Okay, I'm going to change my color to not purple. And then I want to show you how we can test these out algebraically. So in this yellow box along the bottom of the screen, let's test out point A, or check it. We're going to check point A with just algebra, no graphing needed. Take the original inequality, and we don't even have to, you can use either. We can use the original, or we can use the transform version we made, the y is less than or equal to 3x plus 1. Let's go ahead and take the starting one, the way before we changed it, like this. Point A is 5, 1. Remember, 5 is x, 1 is y. There's a space for those in the inequality, right? So those numbers can be substituted in. So let's do that now. So y turns into a 1 minus 3 times x. X turns into a 5. Excuse me. And it says that that should all be less than or equal to 1. So let's simplify the left side. 3 times 5 is 15. So we've got 1 minus 15. And that's negative 14. Is negative 14 less than or equal to 1? Yes, it is. This is correct. So that means 5, 1, point A is a solution. Let's check point D, the one that visually is not shaded. So checking point D now, I'm going to do it in the box. I know I'm running out of space, sorry. That's negative 2, 5. Plug it into the inequality. So 5 is my y, so it's 5 minus 3 times negative 2. Okay, so this turns into negative times negative. That's positive. So this will be 3 times 2, 6. So 5 plus 6. 5 plus 6 is 11. Is 11 less than or equal to 1? No. 11 is greater than 1. So this is not true. So that means that point we plugged in, D, is not a solution. So sometimes we might be able to answer these questions without doing the graph. But you can make a graph and just check it visually. So we've got 2 different tools in our toolbox for checking points to see if they're a solution or not a solution. I'll keep this up for a moment, and then I'm going to grab a couple questions from the mastery test so we can kind of look at those together. And then today's homework for Unit 4 is to do this mastery test. It's called Linear Inequalities. It's number 4, the fourth quiz, fourth mastery test. So give me 1 second. I'm going to stop sharing and add a couple questions. Normally, I would want to have this done, and I'm sorry that I don't. So thank you for your patience. But this morning has been a little weird. Lots of tech issues because I guess the storms, last night started yesterday. And I didn't get to it this morning like I was trying to. Linear inequalities. All right, and let's do one of the word problems too. Okay. Okay, here we go. Thank you for waiting. So this one is going to be just like the last example I showed you. Complete the sentences below by determining whether each point is or is not located in the solution region. Basically, in the gray shaded area, in the shaded zone. Now, another reminder, the points we see listed below, 1, 5, -2, -3, it's x, y. That's what I wanted to remind you of. X, y. So it's always the left, right number first, and then the up, down number second. So looking at these, let's start just at the top and work down. 1, 5. I hope that graph is large enough for you all to see. At 1 comma 5, does that look like it's in the shaded zone, in the white zone, or is it right on the red line, the dashed red line? And if it's too small, tell me that. I just grabbed the whole thing with the words, so I hope so we can see the whole question.
What was the question?
Question is, I'm looking at the first point they gave us right here, 1 comma 5. Does that point lie in the gray zone, in the non-shaded white zone, or on the line itself, on the red dashed line?
I think it's in the white. No. Yeah.
This is kind of a tricky one. I'm not trying to trick you guys, but I'm glad this question came up. And Anaya, that is the I was feeling the same way. I could hear in your voice about it. It's a little hard to tell with this one. Let's do it together. 1 is right here on this space, and then up 5 is right here. This one's actually right on the line. So if it's right on the line, and this is not a solid line, is it? This is a dash line. So that means the stuff on the line is not included in the solution. So because it's not in the gray zone and it's not on a solid line, 1 comma 5 would not be located in the solution region. The gray and the shaded zone is the solution region. Let's try the second one together. -2, -3. So that's left 2, -2, and then down 3. 1, 2, 3. Now here, this one, it's really close, but we can see it. It's definitely in the white zone. It's not shaded. -2, -3. So also the second one is not located in the solution region. I guess my grammar is not good today. The point not be located, I guess I should say it is not. Let me change that. Sorry about that. So both the first and the second are not located in the solution region. The third one, -1, -3. So -1 and then down 3. Boom. This one finally is in the solution region. And then lastly, the point 3 comma 12. That's right 3. That's right here. And then up 12. Uh-oh, it's off the picture. So it's kind of a toss-up, right? Did we guess? Or how can we do this without seeing it in that picture? We can check it algebraically. So really quick, let's put our equation together from the picture like we were doing earlier. So I'm going to take my blank generic mx plus b and we'll start filling in the pieces and the symbol. And then we can test 3 comma 12 in for x and y. So the b value is the y-intercept. So that is 2 because our dashed red line is crossing at positive 2. Slope looks like from that y-intercept, it goes up 3 over 1. So the slope is 3x. So here's our line, 3x plus 2. We could put y in there. Now for the symbol, we're shading below our line. So it looks like our symbol is less than. And because it's dashed, not solid, our symbol is just straight up less than, not less than equal to. So here's our inequality. And we found that by examining the picture. Finding B, M, and then the line itself and the shading told us the symbol. Okay, now we're going to plug in 3 comma 12 in for x and y. So we're checking the final point basically. So y is 12 and 3 is x. as well as slope. I'm plugging in x, y like this. Okay, simplify, and what do we get? 3 times 3 is 9. 9 plus 2 is 11. And uh-oh, this says 12 is less than 11. False. So the point I just plugged in, 312, is not a solution, not in the solution region.
Josiah.
Go for it. Yes.
So one of the things I was going to say is I was kind of thinking that it wasn't going to be in the solution region. And how I figured that out is the point or the X point that you gave us.
Mm-hmm.
I went up from there. And I just like kind of estimated where 12 was going to be on the graph.
Very good. Very good. From 3 for our x, like Levi said, go up 12. I mean, if this is 6, high, this is 7, and this is 8, then we've got to go up, what, 4 more squares? And I know, here's where the estimation, I'm a human. I might be making a mistake on my units, right? But that's how high we'd be going from here. So it's kind of hard to tell. But Levi, good intuition. And Levi used that intuition and just said, it looks like that point is going to be outside, or maybe it's on the line itself. And since it's on the line, boom, it's disqualified because it's a dashed line. So nice job, Levi, with using that intuition and estimating it. I love it. Okay, it's almost 12. I realize I'm keeping you guys late. I'm going to start the next one just to show you what else we might run into. Actually, I'm gonna skip this one because it's writing the inequality from the picture. So we've done that a few times today. It would be good practice, but let's look at this more complicated one. Okay, Mitchell owns a livestock trailer that can hold a maximum of 5,000 pounds. The average weight of each goat is 90 pounds. The average weight of each calf is 360 pounds. Mitchell would like to know how many goats and calves he can support or transport on a single trip. Now, before you even look at the graph, let's try our best to make the equation from the story, just like we've been practicing all semester. For an inequality, it says there's a maximum of 5,000 pounds. So what I'm imagining is each goats added to calves has to be less than or equal to 5,000. All my goats, all my calves added up has to be less than or equal to 5,000. I can't pass that maximum. That's why I chose less than or equal to. Now for the goats and calves. We'll use G and C for goats and calves. And it looks like looking at the picture now, goats they're using for X and calves is Y. So I put them in the right order. I just got lucky. I would have reversed them if they used them swapped. Now, how do we turn this into the proper equation? Let's use those numbers they gave us. So each goat is 90. So let's say 90. You know what? I am going to go ahead and make it X and Y. We've labeled them. So 90X for goats plus 360 Y for calves is less than or equal to 5,000. Yikes. But at least it looks like our normal functions, right? Our normal inequalities. So let's rearrange this guy and we'll see kind of what that looks like. Yeah, we'll go ahead and rearrange it. So we're going to minus 90x both sides. And then we divide by 360. All right. 90 over 360 is, I think, 1/4. And I'm going to keep that as a negative 1/4 x for my slope. It's a little cleaner. 500 divided by 360, this is going to give us a decimal or fraction. 1.39. Wait a minute. What? 500 divided by 360. Okay, I'm sorry. I don't know why I'm getting that. It should have been like, my y value, which is, looks like it's almost 15 or something, maybe 14. The slope does look like it worked out nicely. Okay, I'm sorry to be confusing at the very end of class. Actually, let's stop there for a second. Looking at what they're asking us below, they're asking us which one of these has to be true. So I think this is actually kind of testing us on, assuming that their graph is correct, which I'm going to go ahead and assume it is, and I must have made a weird mistake in my math. These are like our points. So this is another question and kind of checking our points. 42 goats, 2 calves for option A. So we go over to 42, somewhere right here. And then 2 calves. I mean, if this is 10, then I would bet that 2 is inside that shaded zone. But I guess I am just estimating again. I'm not doing it for sure. All right, and since it's 12, I have to let you go for the day. So I'm wondering if I made a mistake with my math on the right. No, how we could try to solve this for sure is use the equation without even changing it and plug in the x and y. Plug in the 42 goats, 2 calves. 42 goats, calves is 2, and see if that's less than or equal to 5,000. And then you could repeat that for B, C, and D. And it looks like only one will be correct and the rest will be false. So thank you guys for coming. I'm sorry that I made it confusing right at the end. I would like you to still try doing this mastery test on your own. A lot of you were answering, Anaya, Levi, were answering some really good questions. So all of you, try answering these today on your own. Tomorrow we'll look at them again together and roll this unit through by Wednesday, okay? As a group. Have a terrific day, and thank you for coming.
Bye.
Bye-bye. Have a good day. Stay safe.
You too.
Thanks, Naya.